Before we begin, we ask ourselves, what is astronomy? According to the American Museum of Natural History, astronomy is the study of the universe beyond Earth's atmosphere. That includes objects we can see with our naked eyes, like the sun, the moon, the planets, and the stars. It also includes objects we can only see with telescopes or other instruments, like faraway galaxies and tiny particles. You question yourselves. How do people before time observe the heavenly spheres above? Who is the father of astronomy? Is it really relevant to learn astronomy in the modern world? What do you think are their contributions in the past astronomy that may impact today? Well, let's find out. Nicholas Copernicus was born on February 19, 1473 at Torun. He was a Renaissance polymath, active as a mathematician, astronomer, and Catholic canon. He is also called the father of astronomy. On his major work called De Revolutionibus Orbium Coelestium, or On the Revolution of the Celestial Spheres, he published it after his death in 1543. It contained his theory of the sun, which is heliocentric model that contradicts geocentric model that validate by the Catholics, as they believe that the Earth was center of the universe. The heliocentric model was based on his celestial observations and mathematical calculations. Although, on his theory, he was aware that there might be a conflict between the Church. By the following year, his theory was embraced by later astronomers such as Galileo Galilei, Johannes Kepler, and Isaac Newton.
Years go by. Galileo was born. Galileo Galilei, also known as the father of modern science, was born on February 15, 1564, near Pisa, Italy. He began to study medicine at the University of Pisa, but changed to philosophy and mathematics. In 1598, he became the professor of mathematics at Pisa. He was also a natural philosopher, astronomer, and mathematician who made fundamental contributions to the science of motion, astronomy, and strength of materials, and to the development of the scientific method. He also made revolutionary telescopic discoveries, including Saturn's rings, planet Neptune, sunspots, and the four largest moons of Jupiter. He also shared this knowledge in a book called Dialogue Concerning the Two Chief World Systems, as he provided the proof and support of Nicola's theories. Galileo was arrested by the Catholic Church, as at that time they were not a fan of Nicola's theory and believed that the Earth was the center of the universe.
Johannes Kepler was a German mathematician and astronomer who discovered that the Earth and planets travel about the Sun in elliptical orbits. He gave three fundamental laws of planetary motion. He also did important work in optics and geometry. As a mathematician, Kepler discovered two new regular polyhedra, worked on the problem of close packing of equal spheres, computed logarithms, and found volumes of solids of revolution. Johannes Kepler's most influential accomplishments in astronomy were his three laws of planetary motion, which were used by Isaac Newton to develop his theory of universal gravitation. Kepler's first law: the planets move in elliptical orbits with the Sun at a focus. He originally studied to be a theologian at the University of Tübingen. He became very interested in astronomy, and his math professor, Mcklein, encouraged his interest.
Isaac Newton, born in England a century after Copernicus. Isaac Newton was a brilliant mathematician and physicist. His theoretical contribution had a profound impact on our understanding of the universe. Laws of motion, which provided a framework to understand the motion of celestial bodies. His law of universal gravitation, which was the one of the biggest and most famous contributions to astronomy. He proposed that every object in the universe attracts every other object with a force proportional to the product of their masses. This explains why planets orbited the Sun in elliptical paths. as observed by Johannes Kepler, which is another key figure between Copernicus and Newton. Copernicus paved the way for a new understanding of the cosmos, which opened the door for more exploration of how the solar system worked. Yet, Newton's law of universal gravitation provided the missing piece. With both Copernicus and Isaac Newton's combined work revolutionized astronomy and shifted their scientific understanding of the universe and really challenged the old way of thinking. Copernicus' proposal of a heliocentric model opened the door. Meanwhile, Newton's law of universal gravitation provided the necessary explanation for how the universe functioned, which all their combined work laid the groundwork for the development of modern astronomy.
In our questions earlier, is it really relevant to learn astronomy in the modern world? Yes, because we use the byproducts of astronomy and have a huge impact on the modern world. Without astronomy, we wouldn't have our satellites to help us navigate throughout the world. It is also one of the main factors that helped us in the creation of the smartphone and computers. Still now, astronomy still helps us in the advancements of both these two objects. What do you think are their contributions in the past astronomy that may impact today? The way of being able to map out the seasons of the modern age creates our foundation to create more specific and more detailed pathways to know which season is about to arrive, and it is also the way that helps agriculturists know which season to plant and farm certain crops.